Hello guys, in this podcast I will show you how to do the independent samples t-test and the dependent samples t-test in Excel. Here's the idea that I have. I want to take my vacation, but one of the factors that I really am interested in is I want high temperatures. So to find that out, I went to this website and got some temperatures for these two places I want to go, Cancun and Punta Cana, right? And I found the low temperatures in the month of January. So I want now to compare these two places in regards to their low temperatures, and the one who the city that has the highest low temperature, that's the place I want to go. Okay, so in this case, right, Excel organizes data a little bit different from SPSS. In SPSS, you'd probably look at a data set like this. Cancun and Punta Cana are coded 0 and 1. Right, 0 equals Cancun and 1 equals Punta Cana. They are in one variable or one column called place, and then the second column would be the respective temperatures. In Excel, you have to put the places or variables or groups into their own column. So, for example, Cancun is right here and Punta Cana is right over here. Okay, so another thing you need to really consider here with Excel is that unlike SPSS that does one procedure for t-test, in Excel you have to do another test before you do the t-test. And that test that you do before is called the f-test, right? Or the test for homogeneity of variances, or the test where you can find out if you assume equal variances or not. Okay, because depending on that particular result, you have to do the t-test. The t-test that assumes equal variances or the t-test that does not assume equal variances. So let's start with the f-test first. You have to go to the Data tab, right, and then find the Data Analysis ToolPack button. If you don't have that, you have to go to the File menu, right, find Excel Options, then go to Add-ins, and in Add-ins, go down here where you see Manage, click Go, and then select Analysis ToolPack, check that box, click OK, wait a minute or so, and then Analysis ToolPack would be right here in the Data tab. So click on the Data Analysis. When you do that, right, you have to go to the f-test for two sample for variances. So click on that particular test, click OK, and now you would see probably two empty spaces. So the first range would be the first variable, and the second range would be the second variable data. One other thing that is very important in Excel is that the variable 1 range should have the largest variance, and the variable 2 range should have a smaller variance, right? Because the f-test is actually the ratio of variable 1 over variable 2, and the f-test would be greater than 1, or should be greater than 1. Right now, I don't really know which one of these variables have the largest variance, but I'm just going to go with a gut feeling, and variable 1 range would be the first variable. So I click on the cell A4 all the way to cell 34, right? And then in variable 2 range, I'll take the second column, right? And I have an alpha level of 0.05. I do not want a new worksheet or new workbook. I just want the output to be right here in this page. Therefore, E5 would be the place where I want the output. So I click OK, and now I have the f-test for variances. Okay, so the f is greater than 1. You know, the gut feeling was correct because the variance of variable 1 is greater than variance for variable 2, right? And the p, or probability value, is a scientific notation. Therefore, I need to change that to a number, and that is 0.00. I want to increase decimals to just see what's going on here, right? Is right the p here? Look at that. That is such a small probability, right? Smaller than 0.05. We reject the null hypothesis that we should assume equal variances. Therefore, we do not assume equal variances. Equal variances are not assumed for this t-test. Okay, so now we know which t-test to do. So we go into this other cell, right? Go to the data, go to data analysis, and now we have to perform the t-test. See how many t-tests are here? one that we want to perform is this one right here, is ttest to sample, assuming unequal variances, right? Because that's why we did the p-value over here, or the f-test. So we click OK. Now variable 1 range is remembered by Excel because we entered that before. Variable 2 range is the same. Alpha level is 0.05. I want now the output to be in the same page. I click OK, and that's what I want. Again, the Excel actually gives you the p-value for one tail and the p-value for two tail. So in this case, I would select these two numbers and then change that to number, right? And then I would increase the decimal. So now look at that. For one tail is 0.000004, and for the two tail is double that number. In any case, this p-value is smaller than 0.05. Therefore, we reject the null hypothesis that there is no significant difference in the low temperatures in Cancun and Punta Cana, and we find out that we accept an alternative hypothesis, which is a two-tail hypothesis, that there is a significant difference. Now, to find out which one had the highest lower temperature, we can go to the means. See this right here? Variable 2 was Punta Cana, variable 1 was Cancun. So Cancun had 64.5 degrees, the average, and in Punta Cana you had 72 degrees on average, right? So even if we had a one-tail hypothesis, where I have hypothesized that Punta Cana would have a higher low temperature, with a one-tail p-value, I can accept that alternative hypothesis because this is smaller than 0.05 and the null would be rejected. Therefore, now I know where I want to go if only my decision was based in the low temperatures. Okay, here's one other thing I wanted to show you. Let's say that you do not have this data analysis, that Excel software that you bought does not come with data analysis. What do you do? The first thing you do, right, is to find out what kind of formula you would want to do. And that was the f-test. So you would start with equal ft, right, f-test, and then you do array 1 and array 2. Array 1 is sample 1, array 2 is sample 2. See, is that easy? So array 1 would be all the data points for Cancun, comma, and array 2 would be all the data points for Punta Cana. Hit enter. Okay, make sure that you know how to change that to a number and then increase the decimals. This is really, really small, therefore you do not assume equal variances because you rejected the hypothesis that you assume equal variances. Therefore, you do not assume equal variances. Now let's do the test. So this is the t-test, right? The t-test now has its own formula, which is a little bit more complicated than the f-test formula. Let me show you. In Excel, you actually, if you press F1 in the keyboard, you'd get the Excel help. Okay, and if you type in t-test here, Excel would give you the t-test formula and argument and the syntax. So the syntax would be array 1, array 2 for two samples, the tails, how many tails you have the alternative hypothesis, and the type. So array 1 is the data for first set, data for second set, tails 1 is for one tail, 2 is for two tails, so you just type number 1 or number 2, and the type, which is the most important thing, is the kind of t-test to perform. So number 1 is for paired variables t-test. Number 2 is when you assume equal variances, and number 3 is when you do not assume equal variances. So in our case, when we type in t-test, right, this type argument here would be number 3. Okay, the two sample unequal variances. Why? Because the f-test tells us that. So we go here in the t-test, we type in equal t-test, right? Double click that. Array 1 would be Cancun, comma. Array 2 would be Punta Cana, comma. Tails, we have it a two-tail alternative hypothesis, so I just type in 2, comma, and the type was type number 3, because type number 3 was when we have an independent samples t-test and we do not assume equal variances. So 3, hit enter. Again, this is a scientific notation, change that to number, right? Increase number of decimals, and this is the t-test. This is smaller than 0.05. You reject null hypothesis, accept alternative hypothesis, and you say that we have enough evidence to show that there is a significant difference between the low temperatures in Cancun and Punta Cana. So that's that. Let's do now the paired samples t-test, or matched pair samples t-test, or dependent samples t-test. I'm going to go to this new sheet here, dependent samples t-test, and what I have here is the temperatures only for Cancun in January and February. Let's say that I chose to go to Cancun, right? But I don't know which month to go. In this case, I want to find out if there is any significant difference between the temperatures in January and temperatures in February. What these are also called are repeated measures t-test, because I measured the low temperatures every day in January, and I repeated that measure, and I measured the temperatures in February. Okay, one thing that you need to really be careful in Excel with the repeated measures or dependent samples t-test is that the two values or the two samples should have equal data points. For example, January has 31 days and February has 28 days. In this case, you have to have the same amount of data points. Therefore, in this case, I'm just going to delete these three data over here so that I have 28 data points. Okay, and that's not a really very big deal here. Okay, let's do the f-test for finding out the equal variances assumption. We'll go right over here somewhere in any empty cell, go to Data Analysis, and then go to f-test toSample for variances, and click OK. And now I'll do variable 1 range and variable 2 range. Again, in variable 1 range you'd have the variable with the larger variances, but since I don't know it right now, I'm just going to do the first variable goes there, and the second variable goes into the variable 2 range. Now, if I find out that the f-test is smaller than 1, then I have to redo this by changing the variable places. Output range would be somewhere over here. Click OK, and that's what I figured. The f-test is smaller than 1, therefore it tells me that the variable 2 range variance was greater than the variable 1. So now I would have to do that again. Let me do that again. Let me do undo here. Okay, and I'll go to Data Analysis, go to f-test again, click OK, and now I would change the B4 to B31 would be on the first variable range field, and the second variable range field would be A1. So in the variable 1 range, I would select B4 through B31, right? And in the second variable, I would select the first variable, and I click OK. Now my f is greater than 1, but the p-value is 0.43. This is greater than 0.05. Therefore, I failed to reject the null hypothesis of equal variances, and equal variances are assumed. With that in mind, I go to Data Analysis to perform the t-test. I go to the t-test sample assuming equal variances, click OK. Right, and now the variable 1 range again would be the second variable, and the variable 2 range would be the first variable. Right, I want the output range in this particular cell right here, so I click on OK, and now I have the t-test here. Okay, so I have for 1 tail and for 2 tail. This is a large probability that our null hypothesis would be true. Very large probability, especially for the 2 tail, is close to 1. What this means is that we fail to reject the null hypothesis, that there is no significant difference in the low temperatures in Cancun for January and February. Therefore, based on this particular criterion, I cannot decide where should I want to go. Either month is fine, January, February, because there is no significant difference. Let me show you something else. The formula, if you don't have Analysis ToolPack, right, the formula is equals t-test. And the equal t-test, we saw that there are 4 arguments. We saw that before. Array 1 would be the second variable. In this case, you have to find the variance for these two variables, comma, array2, comma, tails, I wanted a two-tailed test, and type is, if you remember, right, type is 1, because that is the paired samples t-test. Okay, so I type in here, comma, then I type 1, and now I have this exact same probability as I found it right here. It's not the same, but it's close, right? So this is the t-test for paired. Actually, it should not be equal here. So just a t-test for testing our hypothesis that there is no significant difference between the low temperatures in Cancun in January and February. Okay. Now, one thing that I mentioned here is, why did I put B1, the second variable, as the array 1? I did that because always in a t-test or an f-test, you have to put the variable that has the larger variance before the variable that has the second, the smaller variance, because the f-test is actually the ratio of the first variable that has the larger variance to the smaller variance. Okay. One thing that you can do actually before you do the t-test is to go and find the standard deviation of each of these variables. So you do equal stdev, right? And then you choose the stdevp, which is for the population, right? Because we have all the data points. So you double click that, then select all the data points for that particular variable, hit enter, and this is the standard deviation. You can use the autofill formula to find the other one. And then we see the standard deviation of the second variable is larger than the first variable. Therefore, since the variance is standard deviation squared, then second variable has a larger variance. Therefore, the second variable would be array 1. Okay, so that's that. Use Excel to find out the t-test for paired samples t-test, independent samples t-test when you assume equal variances, and independent samples t-test when you assume unequal variances. Okay, as you can see, Excel is a really powerful tool now to use in statistics. Have a good day.